You've heard that the universe is expanding. But the story of what happens next is far worse than you think. Imagine lying beneath a clear night sky. The Milky Way is a bright river above you. Familiar stars. Familiar constellations. It feels eternal. Then imagine opening your eyes in the same spot, a trillion years from now. The sky is almost empty. No Milky Way. No distant galaxies. Just a thin dusting of red, dying embers where the cosmos used to be. Something has gone very wrong. And the laws of physics say this future is not only possible, it's unavoidable. In this journey, we'll count down 7 terrifying truths about the next trillion years of the universe, and why the last item may permanently change how you think about time itself. I've gone through the latest cosmology papers and simulations so you don't have to. What you're about to hear is the best map we have of the coming darkness. Let's begin. Number 7. Number 7. The end of galaxy making in 2011. A team led by Peter Baruzzi at the Space Telescope Science Institute used Hubble and ground-based surveys to show that the universe's star formation rate peaked around 10 billion years ago, then began to fall. Galaxies are already past their most creative age. On human scales, this is like learning that Earth's population hit its maximum long ago, and every year fewer children are born. Extrapolating forward, by a few tens of billions of years, the cold gas that fuels new stars will be used up or blown away. The universe doesn't end, but its ability to build bright new things does. We have not yet watched a single galaxy live out this entire arc. We have also never seen one escape it. Number 6. The quiet merger in 2019. Gaia data and modeling by R. Michael Rich and others at UCLA refined a dramatic forecast. In about 4 to 5 billion years, the Milky Way and the Andromeda Galaxy will collide and slowly merge into one enormous elliptical system, sometimes called Milkdromeda. Picture 2 cities at night, hundreds of kilometers apart, drifting together over eons until every light blends into one vast urban sprawl. For the universe, this merger will be typical. Gravity will herd local galaxies into a few swollen islands of stars. But because space itself keeps expanding faster and faster, those islands will float alone in darkening cosmic ocean. We have not yet seen our own merger begin. We have also not found any law of physics that will stop it. Number 5. The disappearing universe in 1998. Teams led by Saul Perlmutter, Brian Schmidt, and Adam Rees, using Type Ia supernovae as standard candles, discovered that cosmic expansion is accelerating. This is attributed to dark energy, a mysterious pressure-filling space, recognized with the 2011 Nobel Prize in Physics. On Earth, it's as if every landmark you can see on the horizon began silently sliding away, faster and faster, until one by one they pass beyond visibility. If dark energy stays constant, then in about 100 billion years every galaxy not gravitationally bound to us will recede faster than light from our point of view. Their last photons will arrive, and then, nothing new. Future astronomers will see only the faded remnants of our local group, and the rest of the universe will be not just unreachable, but unknowable. We have not confirmed exactly what dark energy is. We have also not confirmed that it will ever turn off. But what's coming at number 4 changes what forever means. Number 4. The last new star in 2007. A review by Giles Chabrier in Publications of the Astronomical Society of the Pacific explored the mass distribution of newborn stars. Most are small red dwarfs, burning slowly for trillions of years. Larger, brighter stars are rare and short-lived. Imagine a world where nearly every newborn human lives for 1 million years, but births become so rare that you can count them in your lifetime. As gas runs out and galaxies age, star formation will dwindle towards zero. At some point within the next trillion years, somewhere, the universe will see its final new star ignite, and there will be no one there to notice. We have never watched a last star form. We have also never found a mechanism that replenishes galactic fuel on cosmic scales. Number 3. A sky of red embers in 1997. Fred Adams and Gregory Laughlin outlined the stelliferous era and its aftermath in reviews of modern physics. They showed that after about 10 to 100 trillion years, nearly all luminous stars will have expired, leaving red dwarfs and stellar corpses. Think of a city after a permanent blackout. Streetlights gone, neon gone, only a few battery-powered lamps in distant windows, slowly dimming. On cosmic scales, the universe becomes a graveyard of white dwarfs, neutron stars, black holes, and fading red dwarfs. Starlight shifts to the infrared. Night skies in surviving planetary systems grow sparse, then eerily empty. We have not lived long enough to see a single red dwarf complete its life. We have also not disproven that every one of them will. Number 2. The era of black holes in 1971. Stephen Hawking showed that black holes are not perfectly black. They radiate, through what we now call Hawking radiation. Later work, including a 2005 overview by Don Page, calculated that a supermassive black hole of 1 billion solar masses would take around 10 to the power of 99 years to evaporate. On Earth, this is like learning that every mountain, given enough time, will evaporate into mist, not crumble, not erode, simply fade. Far beyond the next trillion years, but set in motion long before, black holes will swallow what remains of stars and gas, then themselves slowly hiss their mass back into the void as a thin bath of low-energy photons. Structure doesn't collapse in some final cataclysm. It just thins out. We have never detected Hawking radiation directly. We have also never found a theory of gravity that lets a black hole last forever. Number 1. Heat death and the end of time. In 1929, Edwin Hubble's measurements of receding galaxies revealed that the universe is expanding. Combine that with the second law of thermodynamics, formalized in the 19th century by Clausius and Boltzmann, and you arrive at the most disturbing forecast we have: heat death. On human scales, imagine every battery, every fire, every wind, every waterfall, all drained until no engine can ever run again. Not because something broke, but because the differences that made work possible have been exhausted. In the far future, long after 1 trillion years, matter decays or is shredded, black holes evaporate, and energy becomes a thin, uniform mist at a temperature just above absolute zero. No gradients, no free energy, no meaningful events. The universe doesn't end in an explosion. It ends in a whimper of perfect, frozen sameness. We have not confirmed that heat death is the only possible fate. We have also not found any evidence that the universe can reset the arrow of time. And now that you know this, you are one of the few who can look at the stars and see not just what they are, but what they are already becoming. Will intelligence find a loophole in these laws, or will our entire cosmic story be just a brief flash between two vast, indifferent darknesses? This is only one future. In the next episode, we'll dive into the even stranger possibilities: cyclical universes, vacuum decay, and how reality itself might end, and begin, again. If you want to be there when that map of the multiverse unfolds, the subscribe button is waiting quietly below.